All right, sixth graders, let's get ready for our Unit 5 test. As a reminder, you are allowed to use a calculator on this test, and I think it would be handy to have one. Okay, the first learning target. I can identify and simplify ratios. A ratio is just a comparison of two numbers. Just like a fraction, we can simplify them and we can have equivalent ratios, but they're not just like a fraction in the fact that we can compare a part of a group to another part of a group. We can also compare a part of the group to the whole group. Unlike a fraction, we can have a big number on top and a smaller number on the bottom. Unlike a fraction, we do not change them into improper fractions because they're not fractions. They're a comparison. So for example, write each ratio in simplest form. Strawberries to pineapples. I count the number of strawberries, 6. I count the number of pineapples, 4. 6 to 4 is my ratio. I can write it like that. I can write it like this. I can write it like this, but I don't want to write it in any of those ways because that's not in simplest form. Simplest form would say to divide both parts by what you can. So I can divide them both by 2, and I would have 3 to 2. I like this way of writing a ratio the best. Remember, order matters. It's very important that I put the number of strawberries first and the number of pineapples second, because that's the only way that we know which one's which, is that we follow the same order the problem gave us. The next one says strawberries to fruit. Even though there's only 2 fruits here, it means all of them. So strawberries, that's 6, and fruit, if I'm counting, would be 10, because I'm counting all the fruit I see. Now again, that's not in simplest form. I can divide both of them by 2, so I get 3 to 5. Another example, I have a table here. Kind of ignore these colors in the middle because it's confusing. They represent 2 Smarties. This is the different colors of Smarties that came in the pack. Write each ratio in simplest form, blue to yellow. So I'm going to find blue, that's 5, to yellow, that's 11. I cannot simplify 5 and 11. There's no number that divides both of them, so I'm done. And red to all colors. So red is 8, and all colors is me taking all of these numbers and adding them up. So 7 plus 8 plus 5 plus 6 plus 11 plus 8 plus 7 plus 3, and that's 55. Now, since there's no number that divides 8 and 55 both, we're in simplest form and we're done. The next learning target. This one's probably the most difficult one and the one we spent the most time on recently. This is where we're setting up a proportion with a rate. Now, we can solve these by finding the unit rate and then applying that, but it's easier to solve these by setting up a proportion. You're always going to have 3 pieces of information and 1 missing thing. So normally they line up pretty nicely where we have the ratios match. Let me tell you what I mean by that. So for this first one, it says, a chef made 30 donuts in 60 minutes. How long would it take him to make 90 donuts? So notice this 90 donuts and this 30 donuts. See how those match? And the thing I want to know is how long would it take, which would be minutes. So I'm going to take my first situation here. Normally they come in the same sentence. So the 2 numbers, they come in the same sentence, and I'm going to set that up. Now this time I'm going to make my ratio look like a fraction because it's a lot easier to set up a proportion that way. So I have 30 to 60. Now I could simplify that. We'll just leave it for now. And then I'm going to set up a second ratio, but this time I'm missing a piece of information. I need to figure out, where do I put this 90? Does the 90 belong on the top of my ratio or on the bottom? Well, when I'm looking at this, the 30 stood for donuts, and the 60, that stood for minutes. Okay? When I look over here at 90, it stands for donuts. So since donuts are on the top, I want to keep donuts on the top over here. And I have 90. Now there's 2 ways to solve a proportion. One way is to look, what I mean by solve a proportion is I want to know what goes there in that missing part of my ratio. So I can look and I can say, how did I get from here to here? I could either multiply or I could divide because these are going to be in order to find an equivalent ratio, we need to multiply or we need to divide. We can't add or subtract. It wouldn't stay a ratio or an equivalent ratio. So I'm going to multiply by 3, and that gets me from 30 to 90. So I can do the same thing. I can multiply times 3, and I get 180. Okay, so how long would it take him? 180 minutes. Another way I could solve this, and for this one, I saw that relationship. I didn't even need to calculate anything. I could see it right away. But what if they were like decimal numbers? They wouldn't be so easy to figure out. And maybe they end up being really ugly when you try and divide on your calculator. So one cool trick is that we can take the two numbers that we see on the diagonal, and I call it crisscross multiply, divide by the lonely guy. So I'm multiplying, we might call this cross multiplication. I'm multiplying 60 times 90. And we know that if I multiply these two things, I should get the same answer as 60 times 90. So 60 times 90, then I'm going to divide by this lonely guy. He doesn't have a partner down here. I mean, pretend like he doesn't, because we are pretending like this is the way we're figuring it out. So I'm going to take 60 times 90, and in my calculator, that says 5,400. Now, I'm going to leave it in my calculator, and then I'm going to press divided by 30 so I don't have to retype it, and I get 180, which is great because that's the correct answer. Let's do another one. 4 big water bottles can hold 8 gallons of water. How much could 10 big water bottles hold? Okay, so I've got 4 water bottles holding 8 gallons. I want to know how much can 10 water bottles hold. So water bottles was my 4, right? That stood for water bottles, and 8 stood for my gallons. So since I know water bottles, I'm going to put that up on top again. Okay, now I realize these last two problems both simplified to be half. Let's go through the process and not worry about seeing this as a, like, oh, I just noticed that they're both half, because they won't be that simple on the test to see the half. So I'm going to solve for the bottom of my ratio. Crisscross multiply, I get 80. Divide by the lonely guy, and I get 20 gallons of water. All right, a pack of 6 cans of coffee cost $12. Oh, I'd like to change this. Let's say it's 3. 3 cans of coffee cost $12. I want to change it because I just realized this one would also simplify to half, and we don't want that. Okay, so 3 cans of coffee cost $12. 3 cans cost $12. Okay, that's my first situation. How much would 15 cans of coffee cost? Well, 3 stood for cans. I have 15 cans. So again, I have my top piece of information. Crisscross multiply, divide by the lonely guy. Or in this situation, I notice that's times 5. And to me, that's easier than getting out my calculator. So 12 times 5 is 60. And it would cost $60. All right. Unit rate. Unit rate means how much is it for just one? Okay, so first, Micah made $19.50 after working 3 hours. How much did he make per hour for 1 hour? So I'm going to take the amount of things, the amount of dollars, and I'm going to divide it by the amount of hours, because I want to know how many of these for every one of these. So whatever I want to change to 1 should be the thing I divide by. Normally they come in order, so you take the first thing divided by the second thing, but not always. We sometimes have to be smarter than the math problem. So how much divided by how many hours? Okay, so my 1950 divided by my 3. So 1950 divided by 3 is, it says 6.5 in my calculator, but I want to write this so it makes sense. It's talking about money, so I'm going to put a $sign at the front. I'm going to add a 0 so it looks like money. $6.50. All right. Soup is on sale, $5 for 4 cans. What is the unit rate? Okay, so I've got $5 for 4 cans. How much is it for 1 can? I'm going to take 5 divided by 4, and I get 1.25. Again, we're talking about money. So instead of saying 1.25, I'm going to put a dollar sign in the front, $1.25. All right, the last one, there are 72 students on 2 buses. How many students per bus? So 72 students for 2 buses. I want to change this to be 1 bus. So I'm going to take this number divided by this number, and I get 36 students per bus. I'm going to use that unit rate again when I calculate the better buy. So here I have 2 different bakeries, Busy Bakery and Tasty Bakes. Busy Bakery sells 12 buns for $4.50. Tasty Bakes sells 30 buns for $10.50. Which bakery has the better buy? In math, when we're talking about a better buy, we're talking about the one that has the cheaper unit rate. So even though it might not make sense that we want to buy a bigger amount, we're still going to say as better buy. The definition of that is to say which one has a cheaper unit rate. So I'm going to take my dollar amount. This time I'm going backwards, and I'm dividing it by the number of things. So I'm taking my dollars divided by the number of things because I want to know how much is it for 1 bun. So if I find out, this one says $4.50 divided by 12. These ones say 0.375. Now that's about 38 cents, right? But we'll leave it with the 5 there just to make sure that we're good. And then 10.50 divided by 30 buns to find out how much does it cost for 1 bun. So 10.50 divided by 30 is 0.35, which is 35 cents. So which one's a better buy? The better buy would be the cheaper price, and the cheaper price would be 35 cents is cheaper than 37.5 cents. So which bakery is the better buy? Tasty Bakes. All right. That is all I have for you tonight. Best of luck. Make sure to bring your questions, and if you've been absent, we can work out some extra question time for you. Have a great night.